In this video, I'd like to talk about word problems with exponential expressions, specifically looking at numerical examples. So, the important point to keep in mind when looking at these different word problems is that an exponential expression is going to contain repeated multiplication, whereas, for instance, a linear expression will contain repeated addition. So let's use that idea and just jump right into these problems. So for this one, the number of bacteria in a petri dish is multiplied by a factor of 1.2 every hour. There were initially 500 bacteria. So which of these expressions gives the number of bacteria after 3 hours? So initially, let's say we'll look at a column where we have time, and we can just call that t. So t for time, and we'll say b is the number of bacteria. So at the beginning, when time is equal to 0, that's our starting point, our bacteria is numbered at 500. And then every hour, we're going to multiply that by 1.2. So let me make just a little bit of room here. So at hour 1, we have our initial 500 bacteria, but now we're going to multiply that by 1.2. So that will be our new total amount. And we could calculate that, but let's just leave it generally for now. And at hour number 2, we're going to take the previous amount of bacteria that we had and then multiply that by 1.2. So we'll take this expression here, this 500 times 1.2, and we're going to multiply that again by 1.2. And for hour 3, we're going to do something similar. We're going to take our previous amount of bacteria and again multiply it by 1.2. So in this case, now we have this 500 multiplied by 1.2 twice. So we can write it as 500 times 1.2 times 1.2. And like I said, we're just going to take this and multiply it again by this 1.2. And the key thing to notice is that by hour 3, you can see we've multiplied by 1.2 3 different times. So we could write this as 500 multiplied by 1.2 to the third power. Though when we look at our answers, we're actually going to see that choice C is correct, where we just have 1.2 multiplied out 3 different times. And in general, with these exponential expressions, let me just make a little bit of room here. They usually look like some starting amount, we can call it A, multiplied by some factor, which we can call B, raised to, let's say, the t power. Where, like I mentioned, that A, that's the starting amount, and B is our multiplicative factor, or we can just call it our factor or our growth rate. And t, in this case, we can call time. Now, it doesn't have to be time, but for many of these problems, the variable will be time. And we can see that the expression we came up with for after 3 hours of bacteria growth, we have our starting amount, that's our A value, multiplied by our growth rate, that 1.2, that's this B value here, and then all raised to the third power. Since 3 in this case, that was our time. We were looking at 3 different hours. So it does match up to this general expression that we'll see in all of these problems. And like I mentioned, for this particular problem, you can see choice C is correct because we have our starting amount and then we multiply repeatedly by this 1.2, and specifically, we do it 3 different times since we're looking at 3 hours of growth.